Oh, hello, and thank you for joining me today. We're going to look at sum and difference formulas today. We're going to work through an example, and I'm also introduce you to the formula for each of them. So the idea is that you have sine of A plus B. That's equal to sine of A cosine of B plus sine of B cosine of A. Now you'll see this in different forms, but this is the form that I kind of stick with. And the way I remember it is that A comes first in the first set. Then I keep the sine and cosine the same, and I switch the A and the B so that B gets associated with both sine and cosine, and so does A, but they do so in different forms. You also have the difference formula, which is sine of A minus B, which is equal to sine of A cosine B minus sine of B cosine of A. Now, again, the only difference between these two formulas is that one has the plus, one has the minus, and they match up. It works differently for cosine, but we'll get to that later. May even be a different video where we do that one. But the usefulness for us is that we can then take, say, cosine, no, strike that, I'm sorry. We can take sine of something like 75 degrees. And we can think of this as being sine of 30 plus 45 degrees. Now, some of you are thinking, well, I can do sine of 75 degrees on my calculator. Why would it be useful for me to know how to split this up like this? Well, some of it is the math behind doing this process is very useful because it just gets us used to thinking in new terms. So just the process of how you think about this. But according to that formula, I can then do sine of 30 cosine of 45 degrees plus sine of 45 degrees cosine of 30 degrees, right? Now, the usefulness at this point is the fact that all those angles, both of those angles rather, are on our unit circle, and we can evaluate that. So I think about my unit circle. There's 30 degrees, there's 45 degrees. This is root 2 over 2 and root 2 over 2 for the y and x coordinate. And this is root 3 over 2 and 1/2 for the x and y coordinate. So then it's just a matter of grabbing the values there and plugging them in. So that's 1/2 times root 2 over 2. And then root 2 over 2 times root 3 over 2. All right? So then it's just multiply straight across like you would fractions. So 1 times root 2 gives us root 2. 2 times 2 gives us 4. All right? And then over here I have root 2 times root 3, which gives us root 6. And then 2 times 2, which gives us 4 again. Now, denominators match, so I can add the numerators, root 2 plus root 6 over 4. Now, that's as much simplifying as we can do at this point, but what we can do is we get our calculator out and plug that into the calculator and find that it's roughly 0.96. Give or take. If there is sine of 75 degrees, you'd find that'd be the true about that as degrees is equal to 0.9-ish on your calculator. So this is your exact value as opposed to a calculator which gives you an approximate value, which can be very useful. Now, if you're going into computer science and you need to program a system of some sort, you'd want to use this process in order to do that evaluation to get the exact value. Now, there are other algorithms as exact values as well, but this gives you a really straightforward process of being able to do that. And this works for just about any angle. Now, in some cases, the angle requires you to do this in multiple iterations for two values, and then you have to do a subtraction for another value, and then you end up with this being 3 or 4 layers deep, but it still works. So you just look at doing this. Now, you can also do this symbolically, which means you, instead of using actual numbers, there you have variables, and the variable process allow you to simplify or value or to establish a proof of some sort. So that is your basic example for sum formula for sine, and I'll post up a couple more videos as well that go along with cosine. And feel free to reach out and ask questions or for additional videos and examples on the same topic. If you will, subscribe and hit the like button.